Ready to dive into some cutting-edge sound and speech tech? We're going deep into the latest research from the Sound Computing Archive, all published just today.
Yeah, we're talking AI that can tell how you're feeling from your voice, hearing aids that can handle any noisy environment, and even algorithms that can tell if you have a leaky pipe just from the sound.
So by the end of this deep dive, you'll be up to speed on how sound and speech technology are changing the world around us.
A sonic revolution.
First up, let's talk emotions. This paper titled Speech Emotion Detection Based on MFCC and CNN-LSTM Architecture really stood out to me.
Oh, yeah, interesting one.
It looks at how AI can analyze your voice to figure out how you're feeling. Happiness, sadness, anger, even surprise.
The cool thing here is that the AI's accuracy changes depending on what emotion it's trying to detect.
Oh, very.
Anger and neutral emotions are the easiest. Like, they hit accuracy rates above 75% for anger and 71% for neutral. But surprise, well, it's trickier.
I guess that makes sense.
Surprise is all about context, and that's a tough one for AI to grasp.
Yeah, I mean, a gasp could mean you're surprised by winning the lottery or finding a spider. Two very different situations.
Exactly. It shows just how complex human emotions really are. Can't just rely on our voices alone.
So does this mean that one day when I complain to my smart speaker, it'll actually understand I'm frustrated and maybe try to cheer me up?
It's possible. This has huge implications. Think about customer service, those virtual assistants, and even, mental health support. All these fields could be revolutionized.
Imagine a virtual assistant that knows when you're down and changes how it talks to you. Or a system that can, flag potential mental health issues just based on how you're speaking.
Exactly.
Okay, let's move from emotions to something a little closer to home.
Yeah.
Hearing aids. There's a paper here on DFingerNet, noise-adaptive speech enhancement for hearing aids.
Oh, yeah.
It describes this deep learning model that could be a game changer for anyone who has trouble hearing. Imagine hearing aids that adapt to any environment and filter out all that background noise without you having to lift a finger.
Yeah, no more struggling to hear a conversation when you're in a busy restaurant or trying to hear over traffic. The secret sauce here is something called in-context adaptation. Basically, the device figures out what the background noise is like and adjusts itself in real time.
And it can do all that without needing a ton of extra processing power. That's pretty wild.
It is.
I'm already thinking beyond just hearing aids. This kind of tech could be used in music production, noise-canceling headphones, you name it.
Oh, yeah. Adaptive sound technology has so much potential.
Absolutely. Okay, let's talk about pushing boundaries. This next paper, an experimental study on joint modeling for sound event localization and detection with source distance estimation, looks at how AI can pinpoint exactly where a sound is coming from in 3D space.
Not just the direction, but the distance, too.
Right.
Think about how we already use sound to navigate the world. This research takes that to a whole new level of accuracy. Think about the possibilities for things like AR and VR.
It could create some truly mind-blowing soundscapes.
Exactly, ones that respond to your every move.
And beyond AR and VR, this could also revolutionize robotics, letting robots use sound cues to navigate, or even security systems, where pinpointing a sound's location could be crucial.
All great applications. This tech has the potential to transform how we use sound in countless ways.
For sure. Now let's get a little more musical. Music Evil, a generative music corpus with expert ratings for automatic text-to-music evaluation, dives into the world of music created by AI.
Right.
We all know that algorithms can write music, but this research tackles a big question. How do you judge how good that AI music actually is?
Yeah, anyone can program a computer to spit out notes. But can AI create something that truly moves us, something musical?
So are they setting a standard for what good AI-composed music should sound like?
Exactly. And this paves the way for AI music that is even more sophisticated and human-like.
Imagine, you describe a mood, a style, the instruments you want, and boom, the AI composes a personalized soundtrack just for you.
Pretty amazing, right?
Personalized soundtracks for movies, games, even just your daily commute. The possibilities really are endless.
Oh, yeah. This is just the beginning of what AI can do with music. Okay, ready for something that sounds straight out of a sci-fi movie? Whisper ASR hallucinations induced by non-speech audio looks at this really interesting phenomenon of AI hearing words that aren't really there.
Wait, so the AI is hallucinating. That's kind of creepy, but also fascinating.
Yeah, it's both. So researchers found that Whisper, a pretty popular speech recognition system, can sometimes mistake sounds for speech, and that leads to errors in transcriptions.
Oh, wow.
The interesting thing is that these hallucinations often involve common words and phrases, almost
Hmm.
like the AI is trying to fit what it hears into something familiar, even if it doesn't make sense in that context.
So it's like the AI is trying to make sense of the world based on what it already knows, but sometimes it gets things wrong.
Exactly. And that raises some questions about how reliable these AI systems are, especially as they become more integrated into our lives.
Imagine a medical transcription AI, misunderstanding a doctor's instructions, or a self-driving car hearing a wrong navigation command. The consequences could be really serious.
Yeah, definitely highlights the importance of testing and research to make sure these systems are as reliable as possible.
Absolutely. Okay, on a more positive note, there's this research tackling a real-world problem with life-saving potential. Noise-agnostic multitask whisper training for reducing false alarm errors in call for help detection looks at making AI more accurate at recognizing calls for help, even in really noisy environments.
Yeah, that's so important for emergency response systems. Imagine someone is hurt in a crowded place and calls for help. This tech could help pinpoint their location even if it's hard to hear them.
That's AI literally saving lives. Powerful stuff.
It is, and it shows how AI can boost our senses and our capabilities in amazing ways.
For sure. Speaking of extending our capabilities, there's this paper called Uncertainty Estimation in the Real World, a study on music emotion recognition. It acknowledges that human emotions are subjective, especially when it comes to music.
Right. We've all been there. One person's happy song is another person's sad song.
Music is super personal.
It is. And AI needs to understand that. This research gets that. It's not just about AI recognizing emotions in music. It's also about recognizing that there's no single right answer when it comes to how music makes us feel.
So they're not just trying to teach AI what emotions music expresses, but also to recognize that people might interpret those emotions differently.
Exactly. It's a big step toward AI systems that are sensitive to individual differences.
Okay, let's move from emotions to something a bit more practical. Water flow detection device, based on sound data analysis and machine learning to detect water leakage, uses sound to detect leaky pipes.
Oh, I saw that one. Pretty clever, right?
It's like having an AI plumber constantly listening for problems.
It is, and it could save people a lot of money and hassle.
Okay, get ready for this one. It's a mouthful. A2SB. Audio-to-audio Schrodinger bridges introduces this technique for restoring and improving audio using something called Schrodinger bridges.
Right. It sounds complicated, but just think of it as a new way to change audio, like taking a bad recording and turning it into something beautiful.
So it's like a magic wand for audio.
Yeah.
You can fix imperfections, even add in missing parts.
Yep. This A2SB model can extend bandwidth so you can add in those high frequencies that make audio sound richer and fuller. And it can do in-painting, which means regenerating lost parts of the audio.
That's amazing.
It is.
Think about the possibilities for music production, restoring old recordings, even creating sound effects for movies and games.
Exactly. AI is pushing the boundaries of what we can do with sound.
Okay, prepare to be amazed. This next one is mind-blowing. SSM2 MEL. State space model to reconstruct MEL spectrogram from the EEG looks at decoding speech from brain signals.
It sounds like sci-fi, but it's closer than you think.
So they're trying to read minds and convert thoughts into spoken words.
It's not really mind reading. They're not figuring out what people are thinking, just how their brains process sound, but they are trying to reconstruct that sound.
Still, the implications are huge. Imagine being able to communicate just by thinking. No more need to speak or type. This could be life-changing for people who can't speak.
It really could.
All right, let's shift gears and talk about research that's bridging the gap between languages. Leveraging cross-attention transformer and multi-feature fusion for cross-linguistic speech-emotion recognition is tackling the problem of recognizing emotions across different languages.
Oh, yeah. Tough challenge.
A laugh might sound the same anywhere in the world, but other emotional cues can be totally different.
Right. Think about sarcasm or irony, those subtle changes in tone. It's super hard for AI to pick up on those, especially across different languages.
So how are they approaching this?
They're basically giving the AI a multisensory toolkit to understand emotions. They're using things like something called HuBERT embeddings, which capture the essence of spoken language, along with MFCCs and things like pitch and intonation.
So they're giving the AI more information to work with.
Exactly. Then they combine all this information using a cross-attention transformer. It's a deep learning model that's really good at finding connections between different types of data.
So it's not just recognizing universal emotions, it's about understanding how different cultures express those emotions.
You got it. And their model achieved almost 79% accuracy across 5 different languages.
Wow.
Pretty impressive.
That's a big step towards breaking down language barriers and creating better understanding between people from different cultures. Imagine a world where AI can help us understand each other's emotions, no matter what language we speak. Okay, let's talk about a paper that's focused on making speech technology more inclusive. GEC-RAG, Improving Generative Error Correction via Retrieval Augmented Generation for Automatic Speech Recognition Systems. It focuses on improving speech recognition accuracy, especially for languages that don't have as much data available.
This is huge for addressing the digital divide. AI models for languages with less data tend to be less accurate.
So they're leveling the playing field for speech recognition.
Exactly. This GEC-RAG uses something called Retrieval Augmented Generation. It basically uses a database of common errors and corrections to improve the AI's accuracy, especially helpful for languages like Persian.
It's great to see AI being used to make technology more accessible.
Absolutely. It's about making sure everyone can benefit from these advances, no matter what language they speak.
Okay, let's zoom ahead to speed and efficiency. FlashSR, one-step versatile audio super resolution via diffusion distillation, introduces a way to make audio sound better that's crazy fast. Remember that audio super resolution we were talking about earlier?
Yeah.
Well, FlashSR takes it up a notch. It uses diffusion distillation. It can achieve super resolution in just one step, way faster than before.
Yeah, and they also made a special vocoder, the SR vocoder. It's fine-tuned for these super resolution tasks, so the audio quality is even better.
So no more waiting around for the AI to process the audio. That's great for real-time applications.
Think about real-time audio streaming. You could have amazing audio quality even with limited bandwidth.
Okay, now let's dive into empathetic AI. Leveraging chain of thought towards empathetic spoken dialogue without corresponding question-answering data. Long title, I know. It looks at how to make AI more emotionally intelligent when it's talking to us.
Oh, interesting.
Yeah, traditional methods for this use a ton of data to teach AI how to respond in an empathetic way. But this research takes a different approach. They're using something called chain of thought prompting.
Chain of thought. What is that?
It's basically guiding the AI through a series of the logical steps. Instead of just giving it an answer, you give it prompts that encourage it to consider how the speaker is feeling. That way, its response takes those emotions into account.
So it's like teaching AI to think more like a human, to consider the emotional side of a conversation.
Exactly. And that could lead to interactions with AI that feel much more natural and empathetic.
Imagine talking to your virtual assistant, and it understands not just your words, but how you're feeling too.
Okay, let's move on to personalization with CEF-PNet. Speaker encoder free, personalized speech enhancement with local and global context aggregation. This one is all about tailoring speech enhancement to each individual and their environment.
Right.
Personalized speech enhancement has always been a bit tricky. It usually relies on complex encoders, which can take a lot of computing power. But CEF-PNet simplifies things. It ditches that separate encoder.
Makes things more efficient.
Exactly, without sacrificing the quality of the personalization. They do this by using information from a sample of the speaker's voice and the noisy environment.
So the AI gets to know the speaker's voice and then uses that to enhance their speech, even when there's noise.
Think about how this could help people with hearing impairments. It could create a much clearer, more personalized audio experience.
Absolutely.
Okay, next up is LLM-supervised pre-training for multimodal emotion recognition in conversations, a paper that blends language models and emotion recognition. It caught my eye because it combines two areas we've been discussing.
Yeah, I like this one. It looks at how large language models, or LLMs, can help AI get better at recognizing emotions.
We've been talking about how important context is in understanding emotions.
Right. One word can have completely different meanings depending on the tone or the conversation around it.
Exactly. And LLMs are great at picking up on those nuances. They analyze tons of text to understand those subtle meanings.
Right. And then they can guide the speech recognition system, helping it to understand the emotions behind the words.
So it's like giving AI a crash course in human communication.
Pretty much. It's an exciting step towards AI that can recognize emotions not just from individual words, but from the entire flow of a conversation.
Before we jump into more specific applications, let's take a look back at 30-plus years of source separation research, achievements, and future challenges.
Yeah.
This paper is like a history lesson on how we've gotten to where we are today with this technology.
Source separation is basically being able to isolate individual sounds from a mix.
Oh, right.
Think about separating the vocals from the music in a song, or picking out one voice in a noisy room.
I get it.
This paper looks at the big breakthroughs in the field, from early signal processing techniques to the newest stuff with deep learning.
It's a reminder that everything we see today is built on decades of research and collaboration.
Exactly. We're building on the work of everyone who came before us.
And it's just the beginning. There's still so much more to discover.
Absolutely.
Okay, let's dive back into the latest research with rate-aware learned speech compression.
In a world where data is king, this one's all about making audio files smaller without sacrificing quality.
It's all about efficiency. Think about those times when your video calls sound choppy or your voice assistant sounds a bit rough. That's often because of bandwidth limitations. This research is using deep learning to create a new way to compress speech so it sounds crystal clear even at low byte rates.
So it's like packing a suitcase. You want to fit everything in without wrinkling your clothes. Exactly. They're getting rid of the traditional quantizer, which can distort the sound, and replacing it with something called a channel-wise entropy model. This lets them compress the audio more without losing the richness and clarity of the original speech.
That sounds like a win-win. Let's talk about making speech clearer in tough environments. Speech enhancement with overlapped frame information fusion and causal self-attention looks at how to reduce delays in speech enhancement.
Yeah, those delays can be a real problem. Like if you're wearing hearing aids and there's a lag between what someone says and what you hear.
Right, it would make conversations so awkward.
Exactly. This research tries to fix that by using information from overlapping frames of audio. It's like giving the AI a broader view of the soundscape so it can make smarter decisions about how to enhance the speech.
So it's not just looking at the current sound, it's also considering what came before and what comes after.
Right. And they're also using something called causal self-attention. That helps the AI zero in on the most important parts of the audio signal, which makes the speech sound clearer and more natural.
Okay, buckle up. This next one is a wild ride. Parameterized quantum circuits for novel representation learning and speech emotion recognition dives into using quantum computing to recognize emotions in speech.
Quantum computing is still in its early days, but it has the potential to change everything, including AI.
It's pretty mind-blowing stuff. So how are they using it to recognize emotions?
They're using something called parameterized quantum circuits, basically programmable quantum devices that can learn really complex representations of emotions from speech. It's like giving the AI a quantum upgrade, allowing it to see patterns that regular computers might miss.
Wow, it sounds like we're just scratching the surface of what quantum computing can do for sound and speech processing.
Definitely. Who knows what the future holds?
Okay, let's shift gears to emotional voice conversion. Durflex EVC. Duration-flexible emotional voice conversion, leveraging discrete representations without text alignment, looks at a new way to change the emotional tone of someone's voice.
Oh, yeah. This is a fun one.
Imagine taking a recording of someone talking in a neutral tone and making it sound angry, sad, or happy. Think about the possibilities for entertainment and creative expression.
Exactly. This research is making that process more efficient. They're using these compressed versions of the audio data called discrete representations.
So they're finding a shortcut, a way to change the emotion without having to analyze every little detail of the audio.
Exactly. And they're doing it without needing a text transcription or timing information. That makes the system more flexible and adaptable.
That's awesome. This could change how we create voices for virtual assistants, characters in games, you name it. It could even help people with speech disorders to better express their emotions.
Lots of exciting possibilities there.
Okay, let's turn our attention to subtractive training for music stem insertion using latent diffusion models. This paper introduces a cool new technique for creating missing instrument parts in a musical track.
It's like magic. Imagine you have a song and you want to add drums, bass, or a guitar solo that wasn't there originally. This research is giving musicians and producers a whole new toolbox for remixing and creating music.
So they're training AI to basically fill in the blanks in a song.
Exactly. They train the AI on tons of complete songs, and then they remove certain instruments and see if the AI can recreate them.
Like a musical puzzle. So how well does it do?
The results are amazing. The AI can generate new instrument parts that sound totally authentic and blend seamlessly with the original music. It's a huge step forward for music creation.
That's incredible. Now let's talk about making singing voice conversion more accessible. LHQ-SVC, lightweight, And high-quality singing voice conversion modeling presents a new way to do it that's more efficient without compromising on quality.
Right. Singing voice conversion, or SVC, lets you transform your voice into that of your favorite singer. But it usually needs a lot of computer power to work well.
So this research is making singing voice conversion possible on a regular computer.
Yep. They made a more efficient model that can run on most CPUs. They did it by tweaking the model's design and using a special technique called a diffusion model.
That's great news for musicians who might not have access to expensive equipment. It makes this technology available to everyone.
Democratizing creativity.
Exactly. Okay, let's explore sound collage. Automated discovery of new classes in audio datasets. It introduces a framework that uses AI to discover hidden patterns and relationships in audio data.
Oh, I saw that one. It's like having an AI archaeologist digging through mountains of data to find hidden treasures.
So instead of just using categories that humans have defined, this system can discover brand new ones.
Yep. It works by breaking down audio samples into their basic sound components and then using a special model to identify potential new categories.
That's amazing. Think about what this could mean for fields like bioacoustics. We could discover new species or animal behaviors just by analyzing existing recordings.
And it's not just for bioacoustics. This is valuable for any field that deals with huge amounts of audio data.
It's like giving researchers a superpower. Okay, let's jump into immersive audio with HuBERT, a large-scale, higher-order ambisonic room impulse response dataset. It introduces HuBERT, a massive collection of HOARs, or high-order ambisonic room impulse responses.
HOARRs are basically recordings that capture the unique sound of a particular space. They take into account all the reflections, reverberations, and spatial characteristics. You can use them to recreate a virtual acoustic environment.
So it's like they built a library of virtual spaces.
Exactly. They used a special technique called the image source method to simulate all sorts of different rooms, capturing all those little details that make each space sound unique. This is a game changer for virtual reality, gaming, even architectural design.
Imagine being able to step into a virtual concert hall and experience the sound as if you were really there. That's the power of HuBERT.
Pretty amazing, right?
Totally. Okay, let's talk about breaking down walls between different tasks in AI with a non-autoregressive model for joint STT and TTS. It explores how to combine speech-to-text, STT, and text-to-speech, TTS, into one unified model.
Traditionally, we've always used separate models for those tasks, which can be inefficient. This research proposes a much more elegant solution, a single model that can understand and generate speech seamlessly.
So instead of having one AI for understanding speech and another for creating speech, they've built one that can do both.
Exactly. And it's non-autoregressive, which means it can process the entire input and output at the same time, makes it much faster.
This could be revolutionary for things like real-time translation. Imagine having a conversation with someone speaking a different language, and the AI translates everything instantly without any lag.
Yeah, and it could also lead to much more natural-sounding and expressive synthetic voices, making interactions with AI assistants much more engaging.
Okay, let's look at how to make federated learning more practical for speech-to-text with communication-efficient personalized federated learning for speech-to-text tasks. This research is about finding that sweet spot between privacy and performance, both super important in today's world.
Federated learning is this awesome technique that lets multiple devices work together to train an AI model without having to share their actual data. Great for privacy, but it can take a lot of bandwidth.
So they're trying to streamline it without compromising user privacy.
Exactly. They're using a couple of different techniques, like FedLoRa, which reduces the amount of data that needs to be shared, and FedMem, which helps to personalize the model for each device.
So it's like creating a custom-made speech recognition system for each user while keeping their data safe.
Yep, best of both worlds.
Now, let's look at ASR error correction using large language models. This research looks at how large language models, or LLMs, can help to clean up errors in speech-to-text transcripts.
LLMs are amazing at understanding language, right? So this research is all about using that ability to make those transcripts more accurate and easier to read.
It's like having an AI proofreader.
Exactly. And they're not just using the most likely transcription, they're using information from all the possible transcriptions, which gives the AI more context to make the best corrections.
That's smart. This could make speech recognition so much more reliable.
Absolutely. Essential for things like dictation, transcription, translation.
Okay, let's talk about a study on zero-shot, non-intrusive speech assessment using large language models. It uses LLMs to assess how good someone's speech is without relying on traditional methods.
It's like having an AI speech coach.
Hmm.
It can tell you how clear, natural, and high quality your speech is without any human input.
So instead of having humans rate speech quality, they're using AI to do it.
Exactly. They're testing a couple of different ways to do it, either by using GPT-4 directly or by combining Whisper, a speech recognition model, with GPT-3 to analyze the transcribed text.
This could be huge for speech therapy, language learning, even voice acting.
For sure. Another example of LLMs changing the game.
All right, let's delve into the world of training AI models to enhance speech with investigating training objectives for generative speech enhancement. These models are designed to clean up noisy or degraded speech recordings, but training them effectively is tough.
It's like trying to perfect a recipe. You got to get the ingredients and the proportions just right.
So they're experimenting with different training methods to see what works best.
Exactly. They're comparing different approaches, like score-based generative models and the Schrödinger bridge framework. They even came up with a new way to measure how well the enhanced speech matches human perception. Pretty cool.
It's all about training the AI to create speech that sounds as natural and clear as possible.
Absolutely. And that's key to making generative speech enhancement a reliable technology.
Okay, let's look at a tool for researchers working on self-supervised learning for speech. Towards automatic assessment of self-supervised speech models using rank. It explores using embedding rank as a metric to evaluate how well self-supervised speech models are performing.
Self-supervised learning is this cool approach where AI models learn from unlabeled data. But figuring out how well they're doing can be tricky. This research suggests a new way to do it using embedding rank.
Embeddings are those representations of data that AI can understand, right?
Yep. So they're basically looking at how the AI organizes the data to figure out if it understands the relationships between different speech sounds.
That makes sense.
And their findings show that this approach is a good indicator of how well the model performs on tasks like speech recognition.
That's a valuable tool. It means researchers can evaluate their models automatically without needing labeled data. Really speeds things up.
Streamlines the whole process.
Okay, let's explore the world of speech foundation models with exploring prediction targets in masked pre-training for speech foundation models. These models are trained on mountains of unlabeled speech data, and they're the foundation for so many speech-related applications.
They're like the building blocks of speech AI. They provide that basic understanding of spoken language that can then be adapted for specific tasks.
So they're like the base of a pyramid, and we can build all sorts of different structures on top of them.
Perfect analogy. And masked pre-training is one of the key ways we train these models. It involves hiding parts of the audio and then training the AI to predict what's missing. This helps the model to learn a really strong general understanding of speech.
It's like a challenging game for the AI,
Yep.
right? It forces it to figure out the rules of spoken language.
Exactly. This research looks at different things the AI can be trained to predict, and they found that some targets, like those related to prosodic features or phonetics, lead to better performance on certain tasks.
So it's all about understanding the nuances of how these models learn.
Absolutely, and that helps us build even better, more specialized AI systems.
Okay, let's move on to a new way to learn about speaker characteristics with Speaker IPL. Unsupervised learning of speaker characteristics with I-vector-based pseudo-labels. This one's all about unsupervised learning, which is training AI without needing labeled data.
Labeled data can be a pain to get. It's expensive and takes a lot of time. So finding ways to train AI without it is a big deal. This research introduces a new technique called Speaker IPL, which uses I-vectors, compact representations of speaker traits, and pseudo-labeling.
Refresh my memory, what's pseudo-labeling again?
It's this cool trick where you use the AI model itself to create labels for unlabeled data. Basically, the model's predictions are treated as if they were true labels, and that helps to train the model further.
It's like teaching the AI to learn from its own guesses.
Exactly. And it works surprisingly well. Speaker IPL is really good at speaker verification tasks, even when it doesn't have much data to work with.
That's amazing. This could lead to much more robust speaker recognition systems, especially in situations where labeled data is hard to come by.
It's a testament to how creative AI researchers are. They're always finding new ways to work with limited resources.
Okay, let's get a big picture view of a rapidly changing field with recent advances in speech-language models, a survey. This paper dives into the world of speech-language models, or speech LMs, which are AI models that can understand and generate speech directly without needing text.
It's a big shift from traditional speech AI. Usually we convert speech to text, process it, and then convert it back to speech. Speech LMs cut out the middleman.
So they can work directly with the raw audio.
Yep. That makes everything simpler, faster, and less prone to errors. This survey highlights just how much progress we've made with speech LMs. They can handle all sorts of tasks like speech recognition, translation, even having conversations.
It sounds like speech LMs are going to change how we interact with computers using our voices.
I think so. They have the potential to make voice interaction much more natural and intuitive. It's a really exciting area to watch.
Okay, let's look at a paper that focuses on making speech recognition more accessible. Using confidence scores to improve eyes-free detection of speech recognition errors, explores how to help people who are blind or visually impaired to spot errors in speech recognition transcripts without needing to see the screen.
Yeah, if you can't easily see the screen, it can be tough to tell if the AI has made a mistake.
Right.
So this research is using audio cues to alert users about possible errors. The cues are based on how confident the speech recognition system is about its transcription.
So it's like the AI is saying, hey, I'm not quite sure about this word. You might want to double check it.
Exactly. They found that slowing down the audio when the AI is less confident made it much easier for users to spot errors. And it didn't make the overall listening time any longer.
That's a great example of making AI more inclusive.
It is. It shows that we need to think about everyone's needs when we're designing these technologies.
Absolutely. Now let's talk about audio array-based 3D UAV trajectory estimation with LiDAR pseudo-labeling. This one's about using sound to track the movements of drones.
Pretty cool, right? Imagine being able to track drones just by listening to them.
So they're creating a 3D map of the drone's flight path using sound.
Yep. They're using a combination of self-supervised learning and pseudo-labeling to train an AI model that can figure out the drone's trajectory just from audio data. They use the LiDAR data, which gives you super accurate 3D measurements, to create pseudo-labels for the audio. That means they don't need a ton of manually labeled data to train the model.
That's smart. It's like they're teaching the AI to learn from a different sense.
Exactly.
Okay, for our final stop on this sound and speech tech journey, let's look at VI 1.5, towards GPT-4o level real-time vision and speech interaction. This paper introduces VI 1.5, an AI model designed for real-time interaction using both sight and sound.
It's like something out of a sci-fi movie. An AI that can see, hear, and understand you all at the same time.
It's like they're building an AI with human-like senses.
Exactly. They're using a special training method that teaches the AI to understand both visual and speech information. They start by training it on tons of text and images, and then they fine-tune it on speech data. That way, the AI learns how spoken language, visual concepts, and the real world all fit together.
That's incredible. Imagine having a conversation with an AI that can not only understand your words, but also read your facial expressions and body language.
The possibilities are endless.
Well, that brings us to the end of our deep dive into the latest advancements in sound and speech technology. We've covered a lot of ground today, from AI that can read emotions to quantum computing to algorithms that can fix leaky pipes. It's amazing to see how quickly this field is moving and how many creative solutions are being developed.
Absolutely. And it's great to see that researchers are focusing on making these technologies more accessible and inclusive for everyone.
It's an exciting time to be following this field. Who knows what incredible breakthroughs are just around the corner.
One thing's for sure, the future of sound and speech is going to be amazing.
Until next time, keep your ears open to the possibilities.